In the last video, we learned what causes an object to start rotating. We need this thing called a torque. We learned what torque was and the basics for calculating a single torque on an object. Now we're just going one little step further. What happens when there are multiple torques acting on something? We'll just learn the approach, and it's pretty straightforward because it is very similar to how you approach objects that have multiple forces acting on them. All right, so let's get started. In the last video, of course, like I said, we learned about what torque was. When you have something that can rotate, for example, a door is attached to a hinge on one side, and people are normally applying forces on the other side. How effective, how quickly we can get this door to rotate, it's based on a handful of things. It's based on a force that's applied, it's based on the location of that force, and then it also depends on what angle is this force acting. If it's perpendicular, that's the most effective, but it could also be acting at some angle. We're not really going to worry about the angle thing in this video. You could apply it based on what you learned last time. Okay, but this is what torque is. This determines the acceleration of a rotating object, particularly if it started at rest. All right, and don't forget the unit of torque is Newton times meters, because that's really just what these two things are. I have meters here, I have newtons here, so the unit must be those two values multiplied together. The very end of the video showed this diagram. And again, it was really approaching the same idea, but this time we have something that can rotate, like a disc that can rotate. And this was a pulley, but this could be a wheel, anything obviously that has an axis through the center and has this disc shape. All right, now last video, we really just applied the single torque equation looking at this force right here. Now we're going to figure out how to approach it when there's multiple torques because there are in fact multiple forces. So two things to recognize. First, just like when we were studying forces, if there are multiple torques, we say there is, or we can find, the net torque, the overall total amount of torque. Okay? Now, if we have torques that are acting all the same way, they make the door or the wheel spin the same direction, we'd add them all up. But if we look at these two forces, they're going to make the wheel want to rotate in opposite direction. So if we kind of ignore this 20 Newton, if we just focus on this right here, this 30 Newton force, if I applied that force, you could probably guess the wheel would want to spin this way, right? Well, if we then just kind of focus, I'll go to yellow, if we focus on this 20 Newton force, if again we kind of ignore this one, it would make the wheel want to spin this way. You might have to take a moment just to figure out, okay, which way would this force want to make that object to spin? Sometimes it's maybe a little tricky. So if I have two forces that are both going to apply torques, how do I figure out the overall torque, the net torque? We're going to approach it like we did for forces. So what I'm going to write, instead of doing the sum of the forces, I'm going to look at the sum of the torques. And there's two torques, and I'm going to use my two different colors. I have this torque in green, and I have this torque in yellow. But wait a minute. We have opposite directions. We have to take that into account. One positive, one negative. What direction should be plus or minus? And now we're talking about rotation. So we're not talking about left or right. We're going to talk about it in terms of clockwise and counterclockwise. And by convention, counterclockwise is taken as the positive direction. You could set it as clockwise, but maybe make sure you label it. Remember how we used to do this? Like up is positive and to the right is positive? Well, we're not really going to do that for rotating things. We're going to do something like this. Make it nice and clear. If it's rotating counterclockwise, we'll say that's positive. There I'm labeling my coordinates. So that's how we're going to approach it. So let's see, which of these two torques is going to be positive? This one right here. So the first one I'm going to write, I'm going to say the torque from the 20. You don't have to write that little subscript, but it's going to help for this video just to keep things organized. We're going to subtract because this green torque is in the opposite direction, minus the torque from the 30 Newton force. Okay, now we're not going to worry about what this equals. That's going to come up in a later video. We're just adding up torques right now. Okay, so you got to remember what torque is. It's the radius, so the radius of that 20 Newton force, how far away it's acting, multiplied by the force from that 20 Newton, minus the radius from the 30 Newton force, which is actually the same in this video, this example, times the force from that 30. Okay, let's plug in. And don't forget, it's R times F. I sometimes see students go from torque and they just think to plug in force. They forget you have to multiply R. And like from the last video, we don't have to break anything into components. What's R? Careful, the diameter is 4 centimeters, but the radius is going to be 2 centimeters. And we have to make sure that's in meters. Okay, so that's 0.2 meters multiplied by the force of 20 minus Again, same radius. Both these forces are acting at the edge of this disk, so it's still going to be 0.02 multiplied by a force of 30. Well, you can punch these two things into your calculator. 0.02 multiplied by 20, that gives you 0.4, minus 0.02 multiplied by 30 gives us 0.6. And what happens when you take 0.4 minus 0.6? You get a negative 0.2 Newton meters. There's my final answer. There's my net torque acting on an object. It's a negative. Does that make sense? Probably, because both these forces are the same distance away from that center, and the force that would make the wheel spin clockwise in the negative direction is bigger. So at least doing a mental quick check, it makes sense that I have a negative answer. Okay, we're going to look at what happens or what these net torques equal later on, and that depends on the scenario. Is the object staying at rest? Is it going to begin accelerating? This is just looking at how to add up torques. Thanks for watching.